Welcome to the deep dive. Today we're heading back, way back, about 230 million years to talk about a really interesting dinosaur discovery from Brazil. It's called Bagualosaurus agudoensis.
That's right.
We're looking at a scientific paper abstract and a news article about it. And our goal really is to figure out why this creature is causing a stir and what it tells us about, the very beginning of the dinosaurs.
Exactly. Bagualosaurus, it means strongly built fellow from agudo, basically. And it lived during the Carnian age. That's a critical time when the very first dinosaurs were starting to diversify.
Right. So finding fossils from then is pretty important for understanding the bigger picture.
Oh, absolutely. They're like gold dust. They help us piece together how those early forms eventually led to all the dinosaurs we know later on. And this one turned up in the Candelaria sequence in southern Brazil, which is already, a hot spot for these kinds of finds. Adds another layer.
Okay, Bagualosaurus. That name is quite evocative. Strongly built fellow.
It is, isn't it? The genus name, Bagualosaurus, comes from Bagual, it's a local word, from Rio Grande do Sul, for a strongly built fellow. The paleontologists thought it fit because of its pretty robust hind limbs.
Makes sense.
And then agudoensis, the species name, that just points to where it was found, near the town of Agudo.
A fitting name. So how did this fella come to light? It wasn't like they just dug it up yesterday, right? I read it was found quite a while ago.
You're right, yeah. It's almost like a bit of a cold case, paleontologically speaking. The actual discovery was way back in 2007.
2007? Wow.
Yeah, they found this quite complete skeleton of a sauropodomorph.
Okay, remind us sauropodomorphs are the ancestors of the big long necks.
Exactly. The lineage that eventually gave rise to giants like Brachiosaurus. This early one were found in a ravine at a place called the Janner Outcrop, and they actually managed to get it out in one large block of rock. Quite the effort.
Must have been. But then, it sounds like it sat for a bit before getting its moment in the spotlight.
It did. For about 5 years, it was in the collections at the Federal University of Rio Grande do Sul, looked after by Dr. Caesar Schultz. It wasn't until 2012 that Dr. Flavio Petter actually started the detailed work, preparing it, studying it.
Right.
And then finally, in 2018, Dr. Pretto, along with Dr. Max Langer and Dr. Schultz, officially named it Bagualosaurus agudoensis and published the description.
Ah, okay. And there's a specific specimen number, right? The holotype?
Yes, that's UFRGS PV Bio 099-T. That's the reference specimen, the one that officially defines the species. So everyone knows exactly which fossil they're talking about.
Got it. So after all that time, from discovery to study,
Yeah.
what condition was the fossil actually in? Millions of years can take a toll.
For sure. It was found in red mudstone. And while parts of it were still articulated, connected together.
Like it wasn't life?
Sort of, yeah. But it had suffered some erosion, unfortunately. Time does that. What's interesting, though, is the position it was found in. Lying on its back with its hind legs pulled up.
Really? Is that common?
Not really, no. It's a bit unusual for archosaur fossils that broader group dinosaurs belong to.
Huh. Any idea why? Does that tell us anything?
Well, the paper doesn't speculate too much, but it's one of those intriguing details. Maybe something about how it died or was buried. It's a little puzzle.
Okay, a mystery within the discovery. But despite the erosion and the odd position, it sounds like they recovered quite a bit of it.
They did, thankfully. Enough to get a good idea of the animal.
So what parts did they find?
Let's see. They found the lower parts of the skull, the lower jaws, 9 vertebrae from the main body, 3 from the hip area, the sacral vertebrae, 2 tail vertebrae.
Okay.
Ribs, some gastralia, those are like belly ribs, chevrons from under the tail, both the main hip bones, the uralia, the right pubis bone, both thigh bones, the femora, both tibiae and fibulae from the lower legs, and most of the left foot.
Wow, that's actually quite a lot. Gives you a good framework.
Definitely. A really significant portion to work with.
Okay, so we're building a picture. How big would this Bagualosaurus have been walking around back then?
Based on those bones, they estimated its length at about 2.25 meters, so around 7.4 feet long.
Okay, so not tiny, but not a giant either. Kind of modest for one of these early sauropodomorphs.
Yeah, exactly. A respectable size for its time, but certainly not competing with the later giants of that lineage.
And diet.
Yeah.
You mentioned the skull parts and jaws. What did the teeth tell us?
The teeth are pretty clear. Their shape, their structure, it all points towards it being mostly, if not entirely, herbivorous.
Eating plants.
Eating plants, yeah.
Yeah.
Which fits the pattern we see with these early sauropodomorphs. They were kind of setting the stage for the massive plant eaters to come.
Right. Okay, so a medium-sized plant eater. Now let's get into the really core stuff. Where does it fit in the evolutionary tree? Why is it so significant?
This is where it gets super interesting. The researchers found that its skull and teeth have similarities to other early sauropodomorphs from the same time and place, like Pampodromeus.
Okay, contemporaries.
Right, but also similar to forms that came later in the Norian age, things like Pantidraco, Afrasia, and the better-known Plateosaurus.
Huh. So, features from different time periods in one animal.
Kind of, yeah. It's what we call mosaic evolution. It suggests that different parts of the body can evolve at different rates. Maybe the head and teeth were adapting more quickly, perhaps to new food sources, while the rest of the skeleton stayed a bit more ancestral or primitive.
Wow, that's fascinating. Like a mix and match dinosaur.
In a way. And that's supported by the rest of the skeleton, the postcranial stuff. That looks more like the earlier sauropodomorphs.
So it really is a blend. Head looking forward, body looking back, evolutionarily speaking.
That's a neat way to put it. It seems to be experimenting with some newer features up front while keeping a more traditional chassis, so to speak.
So it's transitional.
Hmm.
And what about its size in that context? You said it was modest, but how does it compare specifically to those earlier and later relatives?
That's another key piece. It's quite a bit larger. They estimate about 45% larger, based on femur length, than the other sauropodomorphs we know from the same Carnian age.
Okay, so step up.
A definite step up, but it's still smaller than the ones that show up later in the Norian.
Ah, so it sits right in the middle, size-wise, too.
Exactly. It strongly suggests that the trend towards larger body size in this group wasn't sudden. It was gradual. Bagualosaurus looks like a really crucial intermediate step in that process. It helped us understand how these plant eaters started scaling up, maybe responding to different plants or fewer predators or something else.
Right, like finding a specific point on a growth chart that was missing before. And all this analysis, this interpretation, it's laid out in that 2018 paper.
That's the one.
Right.
Published in the Zoological Journal of the Linnean Society, it details all the anatomy, the comparisons, and their conclusions about its evolutionary position. We can link the DOI if people want the technical details.
Great. So let's just sort of pull this together then. Bagualosaurus, this strongly built fellow, gives us this amazing window into sauropodomorph evolution right in the late Triassic.
It really does.
It's a mix of features, some old, some new, and that intermediate size. It really helps connect the dots between the smaller, earlier guys and the bigger ones that came later. That's a key piece of the puzzle.
Couldn't have said it better.
Yeah.
It shows how that body plan was developing. Evolution isn't usually giant leaps, right? It's these incremental changes. And Bagualosaurus is a fantastic example of one of those important intermediate stages. That unique mix makes it incredibly valuable.
So thinking about the listener, why is this story of a 7-foot plant-eating dinosaur from 230 million years ago so compelling? What's the takeaway?
Well, I think it really highlights how our picture of the past is always being refined. You know, every discovery like this adds detail, sometimes changes the narrative. It shows evolution often works step by step. And finding these transitional fossils is crucial for filling in those steps.
Yeah.
And it just underlines how important this kind of painstaking paleontological work is for actually uncovering the history of life on our planet.
Absolutely. It's amazing how one partial skeleton can ripple outwards and shift our understanding. It really gets you thinking, doesn't it?
It does.
What other creatures, like Bagualosaurus, are still out there, buried, holding secrets to these huge evolutionary stories? Thanks for walking us through this discovery.
My pleasure. It's a fascinating animal.
And for you listening, here's something to chew on. Think about how finding just one fossil, maybe incomplete, maybe found decades ago, can fundamentally alter how we see millions of years of history. What other connections, what other transitional forms might just be waiting under the surface somewhere, ready to tell us even more about the incredible journey of life on Earth?